And now we get to value-added networks, which is the intermediary that helps to branch when we have translation issues between documents. So one business is using EDI and the second business is using XML, or one business is using US standards and another one is using European standards. So how do we get those systems to talk to each other? So the use of value-added networks allows for that translation between the different kinds of software systems. When we look at the other services that value-added networks can provide, we might also be able to include security services such as message encryption and firewalls so that we don't have to worry about our data getting out to people that we don't want to have. But the main service being that translation service between multiple systems. An example of a value-added network is an API, or an application programming interface. So an API is a connection that happens that allows various software programs to talk to each other. So for example, if you are using Canvas right now for your course, so and as part of Canvas, maybe you're using publisher software. So you have to click into Cengage or click into McGraw-Hill in order to do homework assignments. That connection between the two different software products is facilitated by an API. The benefit of APIs is that it's real time and they're cloud-based. It happens up to date, it's dynamic, and it allows for that very fast. Okay, so the textbook, when it compares EDI to API, it talks about buses versus Uber, and it talks about how EDI is like a bus. So when you get on a bus and you have to follow a very specific route. Okay, so there's no, if there's a bus stop 4 blocks from where you need to be, there's no way to convince the driver to take you that extra 4 blocks. They're going to stop along the route and they might stop at every route, where an API is like an Uber or a taxi, where it goes exactly where it needs to go directly without stopping at other places. Another type of software system that we can use in supply chain management is called an ERP, or an enterprise resource planning system. So this is the whole number of systems and software packages that a company uses to maintain its business activities. So where our accounting information is stored, where our transactions take place, where we store information about our suppliers, our production, our inventory management, our customer service management, etc. One example of an ERP is MyDot Wartburg in Genzavar. So Genzavar is the ERP system that Wartburg uses to keep track of who's registered in what class, what your grades are, your transcripts, how much money you owe to the college, if there's scholarships that are going on your account. If you work for Wartburg and you clock in and out, your payroll information, all of that information is stored in Gensvar or My.Wartburg, which is their ERP system. Okay. Historically, the implementation of an ERP system was very costly and very complex. And I actually love how they say historically very costly. I've been through ERP software changes at companies. The last time I was involved in an ERP change was at Iowa State, and it cost $5 million to implement that change. So it's still very expensive and costly to do. Not only that, but it took 3 years for that ERP to be changed. So to change over all of the systems to connect different departments to each other in order to test and get all of the bugs out of the system, and then having to train every single employee how to use the new system versus the old system. So it's a complex, expensive, time constrained problem. However, once the ERP is in place, it's a cost saving mechanism. It allows businesses to communicate across departments, to work together. It allows for collaboration. Um, and there's so many benefits to using an ERP system. Okay? Um, Collects data, and we can connect to other supports. So we're going to talk about a lot of different um, data management systems that can be used as part of supply chain management. So, an inventory management software that keeps information about our inventory and how when we want to order, how much inventory, where our inventory is located, who our suppliers of inventory are, etc. Our warehouse management system, where are our warehouses, what do we store in those warehouses, what access do we have to those warehouses, who works in those warehouses, transportation management systems, who do we use as our carriers, do we hire our own fleets, and if we hire our own fleets, how do we maintain our trucks and make sure that they're fully repaired and ready to transport cross country. And then yard management systems. So if we have a lot full of containers and semi trailers, how do we make sure that they're safe, that people aren't stealing from them, that their location is taken care of, etc. Okay. So all of these different various softwares, and of course, each one of these slides is going to go through those a little bit further. I'm not going to take the time to read all of these slides independently. It's just various things that these softwares can help us to plan. So, like, what's the optimal level of inventory to maintain at any location? There's actually mathematical equations for that that we will have to hit in other chapters. One is called the economic order quantities, but we'll talk about those mathematical processes for what an optimal level of inventory is in a future chapter. Okay. Um, so when we look at how much inventory do we want to have on hand, where that inventory should be located. Okay, warehouse management systems, keeping track of where our warehouses are, how we want those warehouses to be optimized, do we want robotics, etc. We're going to talk more about warehouse management in a future chapter. We have an entire chapter devoted to warehouse management. Okay. Then we have transportation systems. We also have an entire chapter, chapter 5 actually, devoted completely to transportation and transportation management. This is just an example of how we can put a transportation management system together and the functioning of a transport management system. Okay, and then yard management systems, as I said, to manage containers and trailers sitting in yards outside of our manufacturing plants, our warehouses, or distribution facilities to make sure that there is no vandalism, theft, that people can't like climb on them and hurt themselves, etc. Okay, and then how do we use all of that information that we have in order to collaborate across our supply chain? So there are multiple different tools. So one is vendor managed inventory. So this is where our supply supplier manages our inventory. Walmart is a company that does this, for example. So Walmart lets their suppliers see into their computer system. And instead of ordering inventory, the supplier looks at the amount of stock available and decides whether or not they're just going to ship more stock. So Walmart doesn't order inventory, their suppliers send it to them when they think they need it. Okay? And then that collaborative planning, forecasting, and replenishment tool, or CPFR, that was introduced in Chapter 2, which helps us develop a single forecast. We're going to talk about the CPFR more when we talk about sales forecasting in Chapter 4. All of these technology tools are necessary to enable e-commerce and business to business transactions and business to customer transactions. And then the last part of this chapter talks about the order management process and how we can use information, data systems, and software through the 6 steps of the order management process. In the next couple of slides, we're going to go through those various steps. So first, order generation. So the supply chain activities performed to obtain a customer order. These include responding to customer questions, preparing estimates and quotes, product pricing, product planning and development, and then the order receipt. How we get that order, is it via in person, on phone, faxed, online, through an app, how we process the order. So choosing that we're going to fulfill the order. Is it something that we have to manufacture from scratch? Is it something that is unique and can be personalized in some way? Or is it just something we need to pick off of a shelf, put into a box, and send in the mail? Then we get to order fulfillment. We go and we get the items that we need, we put them in a box, and we pack them and prepare them for shipment. So these are all our warehouse activities. And when we talk about the warehouse, through the warehouse chapter, we'll talk about the various ways that we can pick items within warehouses, store stuff in warehouses. Then we ship the order. If it's going by plane, train, automobile, truck, if we're using our own shipping facilities, if we're partnering with a third party supplier, and then our post-sale support. How do they post reviews about their experience in the products? How do they contact us for return management? How do they let us know that there's a defect, they need to be fixed, etc. And then how do we follow up with them to get them to make another purchase? Okay. And then beyond just those 6 steps in the order management process, remember we need to integrate across the entire supply chain, and everything that we're doing within our business, we're trying to reduce costs throughout those processes. So where do costs come through order management? One is gaps, that there's some kind of gap in the process that causes increased time in our order cycle, so it's increased time for the customer to get that order. Or we have gaps in the way information is shared, but there's some type of breakdown that creates extra time. A bottleneck. What a bottleneck is where maybe we only have one machine that processes a certain type of specialty order, and if we have more demand than that machine can handle, that's a bottleneck. Um, you know, there could be a wide variety of bottlenecks. Errors. So if we have errors in orders, and then duplication of activities. Duplication of activities is where we're paying multiple people to do the same exact thing. So reducing duplication of activities is always a really good way to reduce costs. When we look at that order management system or any other system, we want to look at a process map. So a process map is where we sit down and we draw out how something travels through our supply chain. And then we connect different things. So where does it enter our facility? What suppliers do we use? How do we get that item? Where does it sit with how does it move through our own organization? And then how does it get from the from us to the customer? Or even how what's our process for taking orders? What's our process for production? How many of those processes are dependent on the thing in front of them happening before they can occur. So when we write that down and make a picture out of it, that helps us to see where we have gaps and where we have bottlenecks and where we have duplication of effort so that we can streamline the process and redesign the process in order to make sure that things flow better in a manageable way. Okay. Then we have future role of information. So new technologies that come out and how we can use those throughout our supply chain. So one is blockchain. So blockchain is an online ledger where information is stored. So information gets stored in a ledger or a block. The blocks are all joined together to form a chain. These blocks or chains keep information about transactions. And in order for a block to be added to the chain, everybody who is in the chain has to agree to a consensus that this block gives true information. Because it's this consensus thing where multiple people have to be involved, it's very, very difficult for counterfeit or theft to happen along the blockchain. And so blockchains are very secure. Because of that security of information and the inability for fraud to happen, a lot of places are really interested in how to utilize this blockchain technology within their business structures. There are still some barriers to entry, though. One is that blockchain is still slow. So, because it takes consensus, everybody that's in the group has to agree. And that can take anywhere from like 5 to 20 minutes to get that consensus still, which 20 minutes is considered slow in this digital age. Another thing is that blockchain takes a lot of power. So currently, the blockchain that runs Bitcoin generates the same amount of power every year as 159 cities added together. It's a massive amount of paper. There is a huge carbon footprint for blockchain technology. And so that's one of the things that has to be figured out before it can really be implemented worldwide or taken to a scalable level is the fact that it's a huge energy usage. Okay. Another thing is called the Internet of Things. The Internet of Things is it allows our devices to connect to us and to each other across the internet. So things like if you have a smartwatch, that your smartwatch can connect to the computer and connect to your phone. Um, these are refrigerators that can connect to the internet and keep track of what's inside your fridge and place grocery orders for you. These are uh, you can get clothing that has sensors in it that keeps track of like how many times it's been washed or how it's been washed to transmit data and information back about how care affects the quality of the material and how long the material lasts. So the Internet of Things, as we have more and more things that connect to the internet, more and more things that connect to others things. So it was created in 2016 to help facilitate all of that stuff. That is the end of chapter 3. When we move on to chapter 4, we'll be talking about sales forecasts and demand.